Here and welcome to the Algebra 2 2025 live stream. So the Regents is tomorrow. First, I just want to say, good luck to everybody. If you're nervous, that's normal. We're going to go through a full Regents, and the Regents we're going to go through is June 2017. So if you want to follow or click the link in the description and, get the test rolling along, then, feel free to click and follow along as I go. So this is the one you're going to go through, and so we're going to go right to the part ones. We have 24 questions here. Each one is worth 2 credits. So let me just zoom out a little bit here, and I am just going to kind of move here, but as you have questions in the chat, I will definitely address your questions directly. But so that's what's going to happen here. I am using a TI 84 CE, TI 84 plus CE. I have it reset to radian mode, so I will show how to use the calculator at different parts. So at Eli, I'm happy to have helped. So hello to everybody here. I'm glad to be on here and working with everybody. So thank you all for joining me. All right, let me just see. Let's see. Burned out. I did 3 regions so far. All right, so at Nick the Gamer. If you did 3 regions so far, like maybe just listening, or even if you drop off early, that's totally understandable. You just kind of pace yourself. Probability for sure could be a little tricky. The key with those questions, I would say, is just patience. Okay, the name of the game is patience. And hello to Mina. I'm glad that you are on. Good luck tomorrow. All right, so first question here. We have a graph of the function p of x. I appreciate the vote of confidence calling me GOAT, but hello and thank you, and I'm glad to have you all on. So which one could be the equation for p of x? So this one, roots and factors are opposites. Okay, so we have this. Roots and factors are opposites. So for this one, my attention is immediately drawn to, we have a root at x equals -3. We have a root at x equals 2, and a root at x equals +3. So if I think of something, I don't know, let's say I write something out like this. So this is random. This is not part of the question necessarily. But let's say I had x squared, I don't know, let's say plus 5x minus 6 equals 0. We play we factor. We look for 2 numbers that add to 5, and the numbers also have a product of -6. So we'd have something like x plus 6 times x minus 1 is equal to 0, because 6 minus 1 makes 5, and 6 times -1 makes -6. The question's not showing on the screen. We can't see. All right, hang on. The test is not, let me see what's going on here. All right, hang on a second. I will fix it. I see what's going on now. All right, I know what it was. I reused my screen share from earlier, so give me 1 minute and I'll fix this. But good thing I have 2 screens going and I'm paying attention to the... so let me just remove screen capture and I'll just re-add it. I'm on OBS. Hang on, we'll get it going here. All right, so let's see. Let's try this. Okay, so there's that. How about now? How we... Oh, that's good. Good thing I checked the chat. Imagine I go through the whole test and I just talk to myself and no one gets any review. Yay, we're back in. Okay. Sorry about that. All right. But let's see. All right, cool. So here we are. We're back in action. All right. So what I was basically saying, though, is that roots and factors have an opposite relationship. So something random. X squared plus 5x minus 6 is 0. Oh, yeah, sorry. I have 2 kids. They're going to go to sleep soon, and then we'll all be able to concentrate. But you might hear random yelling. But they're having fun. Okay, so x plus 6 times x minus 1 is equal to 0. So we get here, and then we set the factors equal to 0. And then the roots are opposite. Okay, so this is borderline Algebra 1 territory. But in Algebra 2, it's a little funkier because you could have 3 roots. You could deal with cubics in Algebra 1, but not typically. So here, when I see this, I'm like, oh, all right, the roots are x equals -3, x equals +2, x equals +3. So I immediately say something like p of x is equal to, remember, roots and factors are opposite. So the x minus 3 root, so if I color code this, like the x equals negative 3 root would give me a factor of x plus 3. The x equals positive 2 would give me a root of x minus 2. I'm sorry, the x equals positive 2 root would give me a factor of x minus 2. And the x equals positive 3 root would give me a factor of x minus 3. So you get here and you're like, oh no, my answer's not there. So then the next thing is they snuck in a little extra algebra. So a plus b times a minus b. And we get a squared minus b squared. Okay, so this is a good formula to know for the Regents. A plus b times a minus b is a squared minus b squared. So notice here that we have x plus 3 times x minus 3. So those two together can multiply to make x times x is x squared, and then 3 times 3 is 9. So we get x squared minus 9 times the x minus 2. And this would be our function here for p of x. Okay, so that's why choice 1. Okay, choice 1 is, yeah. All right. Now, let's say you're like, hey, like that's a lot of stress. You could always, of course, just type this stuff in. Like a Regents at the end of the day is just a test. So, I mean, like the multiple choice, it doesn't matter how you get to the answer as long as you get it right. All right. I mean, of course, for enlightenment, you want to like know how to do this stuff and you want to know algebra. But if I just type in p of x in the y1 equals, then notice what I have here. My picture matches the one in the question here. That I have a root at negative 3, positive 2, and positive 3. So that's why choice 1. Okay? Cool. Alrighty. So moving on. Something like this. Now, once again, let's say you can't algebra this. If you can't algebra, yes, you could. All right, I don't know if you could pass the whole test with just the calculator, but, oh, how would I assume? Oh, yeah. So the rules. Ask questions. I'll do my best to answer, but please be nice to each other. Foul language, hate speech, and/or bullying will not be tolerated. I did have to boot people from algebra and geometry. I like to think algebra 2 people are a little older, so maybe they grow out of it. But please just be here, be nice. That's what I care about the most. All right, is that you? The same rules as my classroom. I care first and foremost that kids are nice to each other. That's more than anything. I don't care how smart anybody is. And then second, I just want to see people try hard. That's it. But if you're nice, like, you know, then I'm happy to hang out in a room with you. Alrighty. So back to the test. So question 2. I'll do this algebraically, and then I'll just do calculator magic. So let's say you want to know, how do I do this with algebra? So algebraically, we have the original equation like this. And first order of business would be to divide both sides by 8. Okay, so get rid of the 8, because it's 8 times 2 to the x plus 3. And now we have 2, I'll write it over here, to the x plus 3 is equal to 48 divided by 8 is equal to 6. And then you look at the answer choices, and notice there's a bunch of natural logs in there. So that's the algebra I'm going to do next. I'm going to take the natural log of both sides. So natural log of 2 to the x plus 3 is equal to natural log of 6. Okay? So what we have from here is we got natural log. If I have something like natural log of a to the b power, that's the same thing as saying b times natural log a like this. All right, so that's the algebra I'm going to do. I'm going to take this exponent in the log, and I'm going to bring it in front. So now I could say x plus 3 times natural log 2 equals natural log 6. Okay, how many multiple choice do you need to pass? Sure, let me answer that. I could talk about that. Conversion chart for this test. This is June 2017. And the conversion chart. So I could throw this in the chat. All right, so let's see. So here's the conversion chart. But for this one, the cutoff was 26. So 13. Just 13 multiple choice. Which is like pretty reasonable. I don't know. That's like not terrible to get 13 MCQs. But I would look at like June 2024, January 2025 to see like what's the new mark here. So yeah, 13. All right, so now from here to get x alone, we divide both sides by natural log 2. All right, now these cancel, and I'll write the result over here. We got x plus 3 equals ln 6 over ln 2. Do not say natural log 3. Okay, the other property to know is when you have natural log a minus natural log b, you get natural log of a over b. Okay, this is allowed. This, don't divide those. You can't divide those. That's not algebra. So now just go minus 3 on both sides. And now you got x equals ln 6 over ln 2, and then minus 3. So this matches up with choice 1. All right. What you could also do, because this is, let's see here. So if I go to the main screen and I go, let's say alpha y equals enter, and we've got ln 6 over natural log of 2, and then minus 3. So if I have this, and then I just press store as alpha math. So I'm storing that decimal as the letter A, and then I go to the original equation here. I have 8 times, in parentheses, 2 to the power A plus 3. Okay, so I just type in the answers for X, and I hope I get 48, and then I get 48. All right, so that's one way of getting there. Cool. Get put. Oh, how did X plus 3 get put before ln 2? So good question. That's this rule. Okay, if we look over here, this is a rule for all logs. If I have, like in general, log base A of B to the C power, this is C times log base A of B. Okay, that's the power property of logs. So it's a good one to know. All right, the trick is, once again, you just type in the answer choice. So you see I type in the answer choice, so I get this value here. So like there, like I type in the answer choice and I get this. Then I press store alpha math to store that as the letter A. And then I just type in the equation, but then the equation, see how I type the expression in, I type in the expression with the letter A and it gives me 48. So that's how I know, oh, the left side equals 48 when this value of X is plugged in. If you plug in the other X's, it's not going to work. Oh, I'm happy to help. All right, let's see. All right, oh, hang on. I got to just, let's see. All right, just silencing. Yeah, remember, it's all right to ask questions, whatever, but trolls will be silenced. All right. If you say something mean, then you're kicked out. So don't say anything mean. Alrighty. So cheap and fast gas station is conducting a consumer satisfaction survey. Which method of collecting data would most likely lead to a biased sample? Okay? Biased means unfair. So the interviewing every 5th customer to come into the station, this is pretty random. So bias means like so when I hear this, like biased, that means like it's sort of like unfair. Maybe unfair is not the best word. Skewed. I don't know if that word helps, if that makes it easier or worse. But skewed. A good way of thinking of that is like, all right, I'm going to do a survey on baseball. How about this? Like the best. I want to do a survey on the best sport. Okay, the best sport, but I'm only gonna survey the baseball team. Like obviously, that's gonna ruin the, how accurate the data is because I'm just surveying the people that love baseball. All right, so it's like kind of a bad study if I do that. All right, so that's what we mean by bias. Like it's like not like it's like not so accurate. It's skewed. So this is random. Random is good. Random leads to an unbiased survey. Interviewing customers chosen at random makes it fair. So not this. Interviewing customers who call an 800 number posted on the receipts. All right, this is looking like it. And I'll get to that in a second. Interviewing every customer who comes into the station on a day of the week chosen at random. So random again means that's fine. The reason why this one though is biased is customers who call an 800 number posted on the, this is like not millennials. So not millennials, not Gen Z. Okay. I would say most likely, sorry, but most likely boomers. Okay. Boomers or like silent generation. All right. That's not like a Gen Z thing or like, so it's be like, oh yeah, just call this number. Like that's going to be older people. All right. So no, I mean, not that there's anything against older people. All right. It's just that's more of their time. You know, old people, I mean, they text, but they're not like they're more into phone calls than they are texting. All right. Yeah, you have to put a number before store for this to work. What formulas do we need to know that are not on the reference sheet? All right, that's a good one. I mean, like something like this. I to the 0 is equal to 1. I to the first is equal to I. I squared is equal to -1. And then I to the third. This is like the main one that you need to know. Because I to the 0 is 1 or I to the first is I is like sort of obvious. This one is less obvious. So this is like a good one to know. I squared is -1. But then if I multiply both sides by I to the third equals -I. Like this. So now for this, knowing all of this stuff. Oh, and I should point out that it repeats every 4. If I multiply both sides by I again, so I go times I on this side, I get I to the fourth equals times I on this side gives me minus I squared. But that gives me minus 1, which puts me at +1. Okay? Puts me back to +1. So that's something to be on the lookout for. Like I to the fourth equals 1. And then I get I to the fifth equals I to the sixth equals -1. And then I to the 7 equals. So just the pattern just keeps repeating every 4 like this. Okay, but this is like the main one to know. So when I do this algebra, first I do 6 times -4 is -24. Then I do x times x is x squared. Then I do I to the third times I to the first. And remember this rule from Algebra 1. A to the b times a to the c is a to the b plus c. So I to the third times I to the first is I to the fourth. And then we have distributing plus 6 times 5 is 30. And we get x I to the third. Okay, but now we get a substitute here. This is -24. X squared. I to the fourth is equal to 1. So we have times 1. And then plus 30x. I to the third is -I. Okay, so I to the fourth is 1. I to the third is -I. And now just simplify here. So you get -24. X squared times 1 just gives you the x squared. And then we get minus 30xi. All right, so this one, like, these are formulas you would have to know that are not given to you, but mainly this one. Okay, like you could say, oh no, I have to memorize all of this, but if you understand concepts, like this is the only like new thing you'd have to know. All right, and then if we look, 4 matches up with choice 2. So lost. I'm sorry at Blissful. I mean, look, if your goal is to just pass, you got to get, let's see, on the new Regents, it was, so let's talk strategy here. Conversion chart. On the new Regents, it was 28 raw score. Okay? So a 28 raw score is 28 raw score is 14 questions right. All right? So that's all you have to be able to do. Okay? So that's, yeah. All right. So next up, question 5. Question 5. All right, these are like kind of annoying, these questions. But if f of x equals 3 absolute value x minus 1 and g of x equals 0.03 x to the third minus x plus 1. Give me 1 second. I just got to grab, let me just see. Get my water. Take a sip. Sorry, a little distracted. I mean, my kids will be to sleep soon. They're just having fun. This is called the Zoomies. Right before they go to sleep, they get a burst of energy. Okay. So here, when they're saying for the equation f of x equals g of x, f of x equals g of x means they're looking for the x equals solution. So the solution is like the x equals when it's f of x equals g of x. So these answer choices right away are out. All right, those are gone. So now, this, we could try to solve this algebraically, but it's going to be a nightmare. That's why for this, you got to know how to use the calculator. Okay, so we go to the calculator. and we go to y equals 3 math, go to the right, absolute value x, hit the right arrow to get out, and then minus 1. Okay, and then we go down. We have 0.03 x to the third. And then we get minus x. So I hit the right arrow to get out, minus x plus 1. Now I press graph, and I'm like, oh no, I can't really see a whole lot. Now, if I press second trace number 5, so second trace 5, and I go here, I press enter 3 times. See how I get negative 0.99, 1.96? But the problem is, that's why I don't like these questions. They're kind of like I gotcha questions. Like 3 is a good answer because it's like, yeah, that's a point of intersection. But it's like for the equation f of x equals g of x. So they just want the x value. So then you go second trace number 5, and you go to the other one. So you go over here, enter, 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 and it's like 0.500, which doesn't match 1. So then it's like, all right, it's probably automatically choice 2, but you're like, wait, 11.29 is too far out there. So then this is a good trick to know. If I go to second graph, and let's say I scroll out a bit, see how like at 11, I'm at 32, I'm at then 35, 38. Like this is going way, way up. Okay. Like by the time I hit 20, I'm already over 200. So what I could do is I could go to window. I can make my X maximum 20 and I can make my Y maximum go up to 200. So you're allowed to change these values. You press graph and now there's the sneaky intersection point. Okay. So they like questions like this where the intersection point is like off the standard 10 by 10 grid. Okay. So, or 20 by 20 because you're going from negative 10 to positive 10. So I go second trace 5, and then I go to the sneaky intersection point out here. All right, that's the sneaky one, and it gives me 11.288, which rounds to 11.29. Okay, so I'll put this over here. And once again, this will, oh wait, hang on, let me just clean this up a bit. So, so I'm just going between mouse and pen. So let's see. Put this over here. So the answer, the intersection point would be at x equals, I'll just write it over here, 11.29. So that's why choice 2 is our answer. All right, kind of like a mean question. This is like I said, not like average. This is mean, like, kind of an unfair sneak attack. Because 3 is a good answer, but it's like, gotcha. Yeah, so it's a gotcha question. I don't know. Some people, I guess, I think it's a bad question. I don't think like the Regents should be I gotcha questions. I think it should be more like just can you do the math? It shouldn't be like this weird, game. All right. Second trace 5. Okay? Yes, second trace 5. Solving it algebraically. All right, if you were to solve it algebraically, it's really unpleasant because the roots come out to something like this, 11.29. So realistically, like you'd have to write f of x. So this is a concept. So this you would have to write as a piecewise function. This would be like 3x minus 1 when x is greater than or equal to 0. And it would be negative 3x minus 1 when x is less than 0 because the absolute value x is only attached to the 3. So then you'd have to set it equal to g of x both times. So if you set 3x minus 1 equal to this, I mean, this is just not going to be pleasant. All right, like, yeah, you could go like this on both sides and then plus 1. But this is not something that you're going to want to factor, okay? It's possible. All right, this is what we call, I believe this is called a depressed cubic. But the depressed cubic equation is like something that they don't teach in Algebra 2. They don't even teach it in pre-calc. It's like some wackadoo formula. Oh, Mr. Cellini, thank you so much for stopping by and saying hello. And yeah, just thank you. I hope your streams are well and best wishes with the rest of your school year and all that. But thanks for stopping by. Yeah, if anyone ever needs help, Mr. Cellini, you could say, I know you do, I believe, global and whatnot, but great guy, great channel, definitely check him out. Fellow YouTuber, also in the grind, teaching, family man and doing YouTube. So yeah, lots of love. Thank you. So yeah, so basically yeah, let me just look up depressed cubic equation is like it's really nuts. All right, so can it be done algebraically? Like, yes, but it's like really just like pretty horrible. Hang on, let me just see if I can find the. Oh yeah, so here, let me just see. So from Wikipedia, Cardano's formula. So I don't want to say no, because like there is a way, but it's like really just insane. Okay, so yeah, look into Cardano's formula for depressed cubics. But if you were to do that at the Regents, like that would be a flex. You would be there for like the full 3 hours just doing that one equation. So it's possible, but yeah. So, yep, yeah. Shout out to Mr. Cellini. All right. I'm glad. See, look, everyone here is studying math. I'm sure you're putting in your work for your other classes as well. I do appreciate having students like all of you that, you all make it worth it. So thanks for being on here. All right, so given the parent function p of x equals cosine x, which phrase best describes the transformation used to obtain the graph of cosine of x plus a minus b if a and b are positive constants? So this would x plus a, this is like one of those annoying things. Like f of x plus a sends like f of x goes left a units. It's like an opposite thing. So these are like the opposite like tricks or the opposite traps if you're not careful. F of x minus a, f of x goes right a units. So I'll just put these. And then if it's f of x plus a, f of x goes up a units. All right, so when it's outside the parentheses, then it's like what it seems like. When it's inside, it's like they trick you. All right, so just be careful with that. So this would be a units left because it's opposite of plus. And then b units down. All right, so left a units, down b units is going to match with choice 4. If you forget, honestly, just plug in numbers. Just be like, I don't know, a equals 1 and b equals 2. So if you're like, oh no, I forgot the rules, I'm so sad. You just, honestly, just pick out numbers. So you go like y equals cosine x. And then we go y equals cosine of x plus a. But a is equal to 1. And I close the parentheses, minus b is equal to 2. All right, I press zoom 6 to put the graph back to normal. So you see how like I follow this point? I'm going left 1 unit and then down 2 units. See that? Left 1, down 2. And that's how I see it. Okay? All right, the solution to this equation here is blah, blah, blah. So for this one, once again, you could just use the calculator and plug in the answer choices. That will work. If you want to do this algebraically, though, a few different ways. So really all I do is I just separate x squared because there's no x term. When you have like ax squared plus c equals 0, if there's no like ax squared plus bx plus c equals 0, like, I mean, this I just go like quadratic formula. Okay, so this one, quadratic formula. Quadratic formula works here. Okay, you can use quadratic formula if you're nervous. Otherwise, this one, when there's no bx, then I just use a shortcut or like sneaky algebra. So I just go minus 98 on both sides. Okay, so 4x squared equals minus 98. Then I divide both sides by 4, like this. And that gives us x squared equals the square root of, oh, hang on, let me do that last, actually. So x squared equals negative 98 over 4. But then we go square root on both sides. Now, this is where students get thrown off. For one, square root of x squared is plus or minus x. Don't say just x. So this would be x equals plus or minus square root of negative 98 over 4. The fact that we have a negative tells us there's going to be an I attached. So goodbye to this, goodbye to this. There's going to be an I popping out. All right, the next thing is like 98 over 4. The square root of that is not 7. So I'm like, probably not this, probably this. All right, and that's just by, like, once again, using, like, process of elimination. However, if I want to do this fully algebraically, this is the rule to know. So when you have the square root of a over b, this is square root a over square root b. All right, also, when there's a negative, the square root of, like, let's say -3, that negative pops out as I and then square root 3. All right, so one thing I could say right away is this is x equals plus or minus I times square root of 98 and then over 4. All right, and now I will use this property. So x equals plus or minus I times square root 98 over square root 4. But now this, I could say plus or minus I times 98 is equal to 49 times 2. So this is yet another rule to know. Square root of AB equals square root A, square root B, as long as like A and B are positive. Okay, that you could do this. So I have 98 is square root 49 times square root 2 over square root 4. And now finally x equals plus or minus I. Square root of 49 is 7. Square root of 2 is square root 2 over square root of 4 is 2. All right, so that's why we're getting plus or minus 7I radical 2 over 2. The I could just get put next to the 7. So that's why 4. All right. Oh, physics, 10,800 joules. I taught physics for 2 years. Yeah, a little. I haven't taught it in a while, but when there was a teacher shortage at my school, they asked me if I would teach physics. I do miss it. Joules is energy. I remember that much, right? Kinetic, potential. I was thinking of potentially, a little pun there. I was thinking of potentially like doing physics live streams, like for the Regents, but I would have to like really brush up and relearn it. And they're changing the curriculum next year, so I don't know how I feel about it. But I'm curious how many people would actually go on for that. I think it would be something interesting. All right, so this question, you got to know period, frequency, amplitude. These are like the big terms to know for trig graphs. They love questions that say graph one full cycle. Okay, so here, a full cycle, so let me just point out, a full cycle is like from one point to the same point. Okay, so if like I'm say up here at like I don't know, like let's say I'm at like 1 and I'm going down to -1. So a full cycle would be like starting at 1 and then going like back to 1 like this. All right, so it's got to complete like the full, like all the way up to 1, down to -1, and then back. So it's got, that's what we mean by one full cycle. So here, when I see this, I'm like, all right, one full cycle is this much. Okay, so this tells me the period is equal to pi, because that's how long it takes to complete a full cycle, from 0 to pi. The amplitude is the high point from the midline. The midline is the line that cuts the graph sort of in half. Okay, so we have a midline is at 0. Okay, so is at like, y equals 0, like this. So then the amplitude is equal to 0.5 or 1/2. So that means like not this answer, not this answer. It's going to be 1/2 and then one of these. But now this is a good formula to know. So, and this is not on the reference sheet. Frequency is equal to 2 pi over period. I could also say that period equals 2 pi over frequency. Okay, those could just kind of swap. All right, now in general, this is your equation. Y equals A sine bx plus c, or you get y equals A cosine bx plus c. So your amplitude, we'll highlight this, your amplitude is A. Your frequency, so let me get that down. The frequency is your B value. And then your midline is the constant at the end. Okay, so when I'm doing these kinds of questions, I just build it up. Now, cosine starts like this. So cosine curves, like typically we go a maximum, and then we go midline, then we go to the minimum, back to the midline, and then to the max, like this. So that's why like we're looking at cosine here, starting on the y-axis, and it has that classic cosine shape. Sine would go like this. It would go midline, max, midline, minimum, back to the midline, like that. Okay, so this would be for, the sine curve here. And I'll write the birth certificate name for sine. All right, so here, when I'm constructing this, I have y equals, my amplitude is 0.5, so I have 0.5, times cosine of b is the frequency. The frequency is 2 pi divided by the period, and we said the period is pi. So the frequency is going to give us 2. So I'd have cosine of 2x, close the parentheses, then plus the midline is 0. So this is just 1/2 cosine of 2x. So that's why 8 is choice 1. All right, we can just type this in the calculator. And frequency tells you, all right, good question. Frequency is how many cycles. So how many cycles are completed, like from 0 to 2 pi. Okay, so typically when the frequency is 1, so like a standard graph here, and let me just, maybe I'll erase this stuff over here. So I'll erase all this. Something like just y equals cosine x. It looks like this. It's like down and up. So this is 0, pi over 2, pi, 3 pi over 2. And then 2 pi, it completes a full cycle. So this is like when frequency is 1. You complete one full cycle from 0 to 2 pi. When you increase the number in front of x, it's like makes it more zigzaggy. Okay, it repeats more. All right, so trig graphs are good to know. They're useful if you're going to take calculus. Like it's not, bad. 85 on chem at Demons. That's really good. Okay. All right, let's see. One of the questions. Yeah, I don't know. I gotta like read these and like see. Some of them it's like hard to answer. I'm gonna do a 6-point question at the end for sure. That's what this is gonna end with. I'm gonna do the whole Regents. All right. So we have a cost model, C of x. The sales price can be modeled by S of x, and the revenue model R of x equals x times S of x. And now we want the company's profit P of x could be modeled by. So P of x equals, I'm just going to substitute piece by piece. R of x is given by this. See, R of x is here. So that's x times the function s. So I have x times s is 30 minus 0.01x. And then after this, we have minus, and then in blue, C of x is given here. So we have, let me just move this over. So let's see. So this one, so you see I'm just plugging it in piece by piece. C of x is 0.15 x to the third, and then plus 0.01 x squared, plus 2x, and then plus 120. Okay, so P of x now, I just solved this out. Equals. So for this one, we just got to be careful here and distribute. We got 30x, and then minus 0.01 x squared. And then I send this minus through to all four terms like this. All right, I'll make that a little neater. Okay. So here I just send the minus through. It's going to change the sign of everything. I get minus 0.15 x to the third minus 0.01 x squared. Then I get minus 2x, and I get minus 120. Okay? So that's the order of operations here. And now I just have to look for like terms. All right, let's see. Yeah, sorry, a little distracted. Kids freaking out over something. They'll be okay. All right, so P of x equals minus 0.15. Oh, the new Regents for Algebra 2 will be easier. Yeah, maybe. I mean, honestly, the way I treat all these changes, like when I go into teaching each year, I'm just like, all right, I'm just going to teach you all geometry or algebra 2 or calculus. Like there's always like minimal changes, but math is like kind of just math. I mean, maybe like 20 years from now, like once, like who knows what the technology is going to look like. They might really revamp it, but it's kind of like just like meh, like just going along with the flow. All right, so for this, now I have these like terms over here. So you see I had negative 0.15 x to the third, And then I get minus 0.01 minus 0.01 makes minus 0.02 x squared. Okay, and if you got to use a calculator for that, no shame in it. Just go ahead and do that. And then we got 30x and minus 2x, which makes 28x. And then we get minus 120. All right, so then it's just a matter of scanning the answer choices here. And 9 is going to match up with choice 2. Okay? How do you know how to subtract them? Well, when you subtract, just know the minus, like the signs all change. Like that's all that's going on in my head when I'm doing this part. I'm like, oh, the signs all change. And then in this line, like here, I'm like, all right, combine like terms. Okay, so that's like the thing I'm looking for. I'm like distribute, but when I distribute a minus, the signs all change. Okay. Aren't they getting rid of the Regents? I don't know. I'm not sure. The Regents, to be honest, like to talk real life, the Regents is a big money maker. So I can't see them throwing it away completely because it makes a lot of money. I don't know how many kids take a Regents or the state math test. Remember, you all took like 3rd grade, 4th grade, all the way through 8th, minus the COVID years. You took those state tests. Those make lots of money, so I can't see them just like throwing them away casually. All right, so yeah. Took geometry 3 times. Yeah, you know what? Well, I'm proud of you for sticking it out at Blissful. So like that shows perseverance. That is like, don't ever see that as a waste. That is character development. Learning how to like not, get the grade you want, and then you're still hanging out in the pocket. Yeah, I don't know. There's like talks of it, but I don't know. They say a lot of things like, hey, we want to do this, and then they don't. So I just kind of like focus on like what's happening, just kind of like week by week. But all right, so here, this is like a marathon of a question. This whole question is 1 page. So here we go. A game spinner is divided into 6 equally sized regions as shown in the diagram below. For miles to win, the spinner must land on the number 6. All right, that was my roommate's name in college, my first roommate. Okay, so for miles to win, the spinner must land on the number 6. So that's what miles needs to happen. After spinning the spinner 10 times and losing all 10 times, Miles complained, the spinner is unfair, right? If you lose, it has to be unfair. So at home, his dad ran 100 simulations of spinning the spinner 10 times, assuming the probability of winning each spin is 1 out of 6. And the output of the simulation is shown in the diagram below. Which explanation is appropriate for Miles and his dad to make? Okay, so he thinks it's unfair. These questions just think plus or minus 2 standard deviations. So it's the mean from the simulation plus or minus 2 standard deviations. So calculator time. All right, so let's see. So the mean is 0.157. And we're going plus 2 standard deviations. And the standard deviation is 0.109. So we go plus 2 and minus 2. So let me go up to this. I press enter to type it. And I change the plus to a minus. And then this is what we need. All right, so let me just drag that down. Expand it a little more. Okay, so now we got everything we need. So here, this means our confidence interval is from negative 0.061 to 0.375. So that means if like one of the events here falls in this range, it's reasonable. It's not unfair. Okay? Why 2 standard deviations? Well, the standard bell curve here, like with normal distribution, like this, plus or minus like minus 2 standard deviations, and then like 0 is like at the mean. This is like minus 1 standard deviation. This is like plus 1, plus 2 standard deviations like this. And this gives you like the middle 95%. Okay, so if your like outcome shows up here on the inside, then it's like, all right, that's reasonable. If your outcome is like out here or out here, then it's like, all right, that's like really unreasonable and it's unfair. Okay, so like that's the idea. Plus or minus 2 standard deviations is like the marker. Okay, but even if you just think about this logically, Like sometimes you could work this out. So basically when his dad ran the simulation, it said like how many times a 6 showed up. So this is like 1/10 of the time. This is 2/10. That's like 2 6s after spinning 10 times. And this would be like 3 6s. This would be 4 6s. And then 5 6s just didn't happen. Okay, so the most was 4. And it happened this many times. And then this is how many times like no 6s showed up. So if you look out of a trial or a simulation with 100 simulations, okay, notice that this is like almost 20% of the time that, no 6s showed up. So you go to this and you're like, all right, the 0, this is like Miles's case. This is like, mainly for Miles. The spinner was likely unfair. No, it was fair because the 0 times happened, a frequency of 20. And also, if we look at this, the 0 is between, is between these two numbers, which means it's in that 95% confidence interval. So we could say here, not that it's unfair. We could say, no, it's likely not. They should just say it's fair. Likely not unfair. It's likely fair because the number 6 failed to occur in about 20% of the simulations. Okay. And it's also between the 95%. The spinner was likely not unfair since the output the player wins once or twice in the majority of the simulation. Yeah, that one's like just kind of like missing the mark. They're just like stating something they notice. But yeah, interesting question to take up a whole page. All right, which binomial is a factor of this? So I want to point out, if you're like, oh no, I can't algebra. What you could do here is, dividing this would that take too much time? Let's see. If I take out x squared, I get x squared minus 4 times x minus 2. Yeah, this one you could do algebraically, but I'll also show you how to do this with the calculator. Okay. No, I wouldn't say this is outdated. I think the math is still, algebra is still algebra. But if you feel good about all the recent Regents, then, you should be good to go for tomorrow. I made all the Regents videos on the new stuff. That's why when I live stream, I do the old stuff. Because I don't want to, live stream something I already made a video on. Because it's just, sort of, unnecessary. But, it's nice to just connect with everybody. Wow, 228 of you are on. So I will say, if you haven't subscribed and this is helping or the other videos have helped, please subscribe and help spread the word. Okay. So here, if I do this algebraically, I take out an x squared and I take out this. But then what I could do in the next line, I could say x squared times x plus 2, x minus 2. This is a difference of two squares. Minus 4 times x minus 2. And then notice a common factor is x minus 2. So then this is x minus 2 times, I have x squared times x plus 2, and then minus 4 left. And this, if I had to simplify, I could. This is x minus 2 times x to the third plus 2x squared minus 4, and then x minus 2 would be our factor. Okay, so that's, for 11, you should get 1. But let's say you're like, whoa, what just happened? Let's say you're like, no, thank you. Okay, so no, thank you to all this algebra. Well, factor. Remember, factors and roots are opposite. So if x minus 2 is a factor, that means x equals 2 is a root. So you could just go to the calculator and you could type in the original expression here. Okay, and see if x equals 2 is a root. All right, so we got x to the power 4 minus 4x squared minus 4x and then plus 8. Okay, so we do this. I could even graph it, but second graph, I go to the table. And when x equals 2, I have a root. All right, this would mean x equals negative 2 is a root, but x equals negative 2 does not give you 0. It gives you y equals 16. All right, at 4, we have 184, and at negative 4, we have 216. So these are not factors because they don't go in evenly. All right, so definitely 1. All right, given that sine squared plus cosine squared equals 1, And sine theta equals negative root 2 over 5. What is a possible value of cosine theta? So for this one, you have to know this. ASTC. All students take crack. Nope, not that. All sine, tangent, cosine. So this, when I hear sine theta is negative, all the trig functions are positive for angles that terminate in quadrant 1. So we're not in quadrant 1. Theta is not in quadrant 1. Sine is positive in quadrant 2. Okay, if you plug in, like, let's say, I don't know, like if theta equaled 120, sine of 120 is positive. It's greater than 0. All right, so we're not in quadrant 2. That means we're in either quadrant 3 or quadrant 4 here. Okay, so sine theta equals negative root 2 over 5. What is a possible value of cosine theta? So, you know, for this one, there's a few different ways we could go forward with this. But one thing to notice here is that they're going with all positive values here for cosine theta, which means like we're going to be targeting quadrant 4. All right, so we do this in quadrant 4. And the way I like to do this is I draw this out. And for this, you have to know the concept of like, what is a reference angle? Okay, so I draw a right triangle, and my right angle is always on the x-axis. So like concept-wise, it's like this is angle theta, and then this over here, that's our reference angle on the inside. Okay, that's going to help us answer this. So now know SOHCAHTOA. So since we know sine theta is this, that's opposite over hypotenuse. So opposite of the reference angle is radical 2. And the hypotenuse I could just call 5. So if I want to find out like what's my x over here, I could use Pythagorean theorem. Okay, I could say x squared plus radical 2 squared equals 5 squared. And now we solve this out. We've got x squared plus 2 equals 25. And then just go minus 2. So x squared equals 23. But now when I take the square root of both sides, remember, we're in quadrant 4, and the x's are positive. So that's why I'm just going to say x is radical 23. Okay, so now I go back to this diagram here, and I make that x, should have erased it, I make it into a radical 23. So cosine of theta would be equal to cosine of the reference angle. And we're in quadrant 4, so it's going to stay positive. And cosine of the reference angle is radical 23. See, cosine is adjacent over hypotenuse. So adjacent to the reference angle is radical 23 over hypotenuse 5. Okay, so that's why 12 is choice 2. Like this. There is, of course, an easier way. All right? The easier way is like if you're like, oh no, I don't want to do all that. Then you just... I guess we could have also used this formula here. Yeah, maybe I should have just done that. All right. Well, see how sine theta is this? So I could have just gone like, all right, negative radical 2 like this, and then like over 5, and then square it, okay? And then like that plus cosine squared theta equals 1. So I could do 1 minus this. So 1 minus this, and then square root of that. So square root of, actually, let me just go up and put this here. And then we're like, all right, radical 23 over 5. And see how they match? So like, yay, they match. Okay, cool. Another cool trick is you could even just go like this. You could do sine inverse of negative root 2 over 5. So do this. And that'll tell you in radians what the angle is. If that bothers you, you could always, like, for this one, go to degrees. So, like, let's say you don't want to think in radians. You're like, no, thank you. Your angle is negative 16.4299 degrees. So that's like your quadrant 4 angle. If you want it to be positive, you could always go plus 360. Like this. And you could just do, like, cosine of that. And see how you get the exact same thing? You get radical 23 over 5. So like just, I don't know, for these, like if you know trig, you could just figure it out. So some good stuff. Alrighty. Oh, these ones. I don't like. Yeah, these questions are kind of annoying. Alrighty, so this one coming up. A student studying public policy created a model for the population of Detroit, where the population decreased. All right, here we go. Decreased 25% over a decade. He used the model P equals this, where P is the population in thousands and D decades after 2010. Another student, Suzanne, wants to use a model that would predict the population after Y years. Okay, so from decades to years. And Suzanne's model is best represented by. Okay, so we got to think about this. If we look at the original model, P equals, let me just make this a little neater. So P equals this. I'm just going to rewrite it over here so I'm not like drawing into the question. This is in decades. Okay, the problem though, think about this. Like if I said, hey, 30 years. 30 years is equal to 30 divided by 10 decades. Okay, that's 3 decades. So anytime you want to go from years to decades, you divide the years by 10. All right, so when we're talking about Suzanne's model, well, for Suzanne's model, we could just say P equals 714 and then 0.75. But if Y is in years, remember, we divide the years by 10, and that tells us how many decades. And then it would match the student from the original student's model, okay, before Suzanne came in the picture. Okay, so their model was in decades. So if we want to match it to their model, see, they're in D decades, and Suzanne is in Y years, we take the number of years, we divide by 10, and that would tell us decades. And now their models match. Okay, but now for this is where it gets a little funky. Okay, so the next phase of this is knowing this rule. A to the B to the C is equal to A to the B times C. So this, I could say, is equal to 714 times 0.75. And Y divided by 10 is the same thing as 1/10 times Y. And now this, I could say, is P equals 714 times 0.75 to the 1/10 power. But now this raised to the Y power. So you see how I could do this rule, but I'm doing this rule backwards. Okay, so that's what makes this topic a little tricky, is we're doing this rule, but backwards. So I'm taking that product, and I'm turning this exponent into a power to a power. And now this is where I ask the calculator, like, hey, what is 0.75 to the 1/10 power? And then I get, let's see, 0.972 or 9716. I'll stop at, because in the answer choice, it goes 9716. So 0.9716. Okay, so this part, now we get 714 to the times 0.9716 to the Y power. So just in case you're like, whoa, what just happened algebraically? This 0.75 to the 1/10 is equal to this. And I forgot to write a 1, sadly. All right, let me just see. Let me fix that. All right. So 0.716. Okay. So that is where this one's coming from. All right. So this one's like kind of like unit conversion. It's a little bit of a funky question. I know like students will complain about these. Everyone's getting a hundo. I hope so. All right. So here we are. Probability. Everyone's favorite. Let me take a sip of water to reach. Oh, wow. We're almost an hour in on question 14. All right. So let me move a little bit. All right. Probability that Gary and Jane have a child with blue eyes is 0.25. The probability they have a child with blonde. All right, so I'll just say this, like probability of blue eye child is 0.25. Probability of a blonde is 0.5. The probability they'll have both. All right, so I'll just say like probability of blue and blonde, okay? So if we have both of these, then the probability they'll have both is this. Okay. Given this information, the events blue eyes and blonde hair are? Dependent, independent, mutually exclusive. Mutually exclusive is like if things cannot happen at the same time. All right. That would be like flipping heads, flipping tails. Okay, and this is like, let's say in one coin toss. So it's impossible for you to flip heads and tails in one coin toss. So that's what mutually exclusive means. These events here, though, are not mutually exclusive because you can have a kid with like blue eyes and blonde hair. All right, so that's why that one is out. So it's either going to be dependent or independent. So for this one, the probability of having a blue-eyed kid is 0.25, which this is the same thing as 1/4. And I'll just point out here, independent is when the probability of A and B, and that means end, equals the probability of A times the probability of B. All right, so that's what we're going to check here. We're going to do the probability of the first event times the probability of the second event, and that equals 1/8. And 1/8 is equal to 0.125, which equals the probability of blue and blonde. So these are independent of each other. So 14 is going to be 2 only. Okay, it's not dependent because you can't be dependent and independent. Okay, if these were not equal, like let's say this was like 0.12 without the 5, then these events would be dependent on each other. All right, cool. Is there an easy way to memorize the probability formulas? I mean, is there a nice way? All right, I understand them from like Venn diagrams. So it's like A, B, and then this is like, like the overlap of A and B. So like that helps me understand why when it's like, let's say A or B, the probability of A, like or B, this is or, is equal to the probability of A plus the probability of B, but then minus the probability of A and B, something like this. Because if you think about it, if I add the probability of A and I add the probability of B, see how I add the overlap twice? So the probability of A happening or B happening, if I add probability of A plus probability of B, the overlap gets added twice, so that's why I have to subtract it out once to count it exactly once. So like Venn diagrams help me understand why the formulas work. That's the best I have for you. Otherwise, enjoy having a spongy brain and being able to remember stuff, because when you get older, your brain starts to go. All right. So based on climate data that has been collected in Bar Harbor, Maine, the average monthly temperature in degrees Fahrenheit can be modeled by this function. And the same government agency collected average monthly temperature data for Phoenix. Okay, so it's Maine versus Phoenix, and found these temperatures to be modeled by blah, blah, blah. Which statement can not be concluded based on the average monthly temperature models X after starting data collection? All right, so let's see. All right, hang on a second. Sorry, I just had to tell my kid good night. All right, so here we look at this one. And the average monthly temperature variation is more in Bar Harbor versus Phoenix. The midline, they're talking about midline, maximum, minimum. Okay, so this is back to what a trig graph tells you. So y equals, and I'll write it in sign form. So this is your midline. Okay, midline, frequency, and amplitude. Okay, so for this, what we got for B of X, we have, so I'll draw this here, the midline is at 55.3. Okay, and now the amplitude is like roughly 24. Okay, so if I add 55 plus 24, 79, it's like going up to like around 79-ish. And then 55 minus 24, 31 would be down here. Okay, so this would be like, it's going up, down, like this. Okay, so that's what I'm kind of seeing here with this part. Like this part on the inside doesn't matter as much because they're asking us about the average monthly temperature variation. So the variation is like the max. Variation is like the max minus the min. Okay, the midline is like just the midline. The max average is like this is the max. And then this is the min. Okay, so that's like really what they're asking about here. And then I just do the same thing for the Arizona, the Phoenix chart here. So P of X, this is for Phoenix. And let me make that a little neater. So Phoenix is at 86. All right, so this is like way up there. Okay, so like 86.7-ish. And then the amplitude is 20, just about 20. So this would go up to like 106.7-ish if I go plus 20. See, I'm going like plus 20-ish. And if I go minus 20-ish, that's going to give us 66.7. So this one's going to go something like this. All right, like that's our Phoenix graph. So when we look at all of this, the, let's just see, is, I'm just reading this one out. 20 degrees. The minimum. All right, so let's go through them now one by one. So the average monthly temperature variation is more in Bar Harbor than Phoenix. Well, the variation for Bar Harbor is, if we look, we're just basing this on like the graphs here. Okay, so if we take a look here at this graph and then look at this graph, we want to see like what's the jump here from the midline to the high and then the low. All right, like that's the the main idea for question 15. All right, and then we go through the other ones. The midline average temperature for Bar Harbor. So yeah, once again we're focusing. Oh wait, whoops, sorry, we're wait, my drawing pad is like kind of new, so it's like just moving around a little bit. Yeah, so for this one here, the average monthly temperature variation is more in Bar Harbor than in Phoenix. So let's just see here. And for this, you know what? I could even, I'm trying to think here. What's like the nicest way to go through this? Starting at 55, starting at 86. All right, you know what? I'm just gonna go. Yeah, I'll reason out the other ones a little bit more carefully here. Yeah, sorry, like the thing started scrolling here, so I'm just gonna move on to this one here. So let's see. The midline average monthly temperature for Bar Harbor is lower than. So we want which one can not be concluded. Okay, which one here cannot be concluded? Well, this first one, once again here, this one is true. The average monthly temperature variation is more in Bar Harbor than in Phoenix. And that has to do with the amplitude. The amplitude is how much it's jumping up and down from the midline here. So you see how here we have an amplitude of 23.9 versus 20. So this one is like a cannot. So like this one works. The midline average temperature for Bar Harbor is lower. Yes, because Phoenix is hotter than Maine. I mean, that you could just think about. But see how the midline is higher in Phoenix than it is in Maine? So this one is out. And then we have the maximum average monthly temperature for Bar Harbor is 79 to the nearest degree. Yep, that we found. So process of elimination, it's this one. But let's see why. The minimum average monthly temperature for Phoenix is 20 degrees Fahrenheit to the nearest degree. I mean, if you just think about that, Phoenix just never gets that cold, like ever. I have 2 friends that live in Phoenix. So, yeah, that's a nice question. All right, but it's a cannot. All right, let's see. Let's move on to this one here. So now, let's see what we got. For x not equal to 0, which expressions are equivalent to 1 divided by the 6th root of x? So I'm going to write this out. 1 divided by, so, and then we have the 6th root of x. So this one, we got to know this idea. This is a to the b over c. So this I could say is 1 over, invisible power is 1. So this is x to the power over root. So just remember, I'll write over here. This is like power over the root. See, we have our root and we have our power. Okay, so power over root, power over root. So if we look, this though, I could also say a to the negative b is 1 over a to the b. So 1 over x to the 1 over 6 is the same thing as x to the negative 1/6. So this one is equivalent. All right, now if I go through Roman numeral 1, this I'll write over here is x to the power 1 over 6. So power 1 over root 6 divided by x to the power 1 over root 3. And this becomes x to the 1/6 minus 1/3. Okay, I'm just using more algebra. So we get this. And from here, this is x to the 1 over 6. 1/3 is equal to 2 over 6. So now this becomes, see, I just go times 2 times 2. This becomes x to the 1 minus 2 is negative 1 over 6. So this one also works. All right, this one also works. But even if we look, see how this is x to the 1 over 6 divided by x to the 1/3? This is also the same. So it's all of them together. All right, cool. Yeah, it's kind of a weird question, but whatever, it's our question, and we answered it. Okay, so moving on. Oh, wow, 1,400 of you stopped by to review Algebra 2 the night before your Regents. I'm very proud. If you haven't subscribed yet, consider clicking. Let's, keep the subscriber count moving. All right, let me just see. Oh, hang on a sec. Hang on. Let me... Okay. Cool. Alrighty. So, moving on. Sorry, just monitoring the chat, silencing people as I go. Okay, so we have a parabola has its focus at 1, 2. So, concepts for these questions. A parabola is the set of all points that are, equidistant from a focus and a line we call the directrix. Okay, so that would be, let's say, a sad parabola opening this way. See how all of these points on the parabola are the same distance away from the focus as they are from the directrix. Right, that's what a parabola is. So parabola is the set of all points that are the same distance away from a point and a line. So when they do that, I'm like, all right, let me just draw this out. The directrix is the line y equals negative 2. So there's the directrix. And its focus is at 1, 2. So that's over 1 and then up 2. Okay, and this was at negative 2 down here. So this is like negative 1 and negative 2. And they're telling us the focus, once again, is at 1, 2. So here's our focus, and this was our, directrix. So that concept of every point on the parabola is the same distance away. So the first one, the vertex, is always either right above or below the focus, and halfway between the directrix and the focus. So that's where the vertex is going to be. The vertex is going to be at 1, 0. So the vertex is at the point 1, 0. So if you think of y equals a times x minus h squared plus k, this is vertex form. And hk is our vertex. This is going to be y equals a times x minus 0 squared and then plus k. All right, so this will once again give us part of the answer. So, oh wait, I'm sorry. I wrote out x minus 0. I should have wrote, sorry, long day, everybody. Okay, so x minus 1 squared plus k. And k is equal to 0. So I'll just write out that, plus 0 at the end. So you see I plug in h and I plug in k. So y equals a times x minus 1 squared. So these answers are gone. It has to be x minus 1 squared, one of those. But now, look, I could, attempt to draw this and be like, it's going to look something kind of like this. Maybe it looks like it's opening kind of wide. So if it's opening wide, it's more likely to be choice 4 than choice 3. You could draw this and sort of figure it out. But the formulas they give you or they don't give you this one. But this is the the idea. When you're looking for the value A is equal to 1 over 4p, and p is the distance between the focus and the vertex. Okay, so you can see here, the vertex is at 1, 0. The focus is at 1, 2. So the distance between them, p is equal to 2. And if p is equal to 2, that tells us here that we're going to have y equals 1 over 4 times 2 times x minus h squared plus k. And this is going to give us y equals 1/8 x minus 1 squared. So that's why choice 4. All right, so drawing it will eliminate 2 choices, but knowing this little formula will get you the last one. I have gone through proofs of why this formula works. That's the only reason why I'm able to remember all this stuff, is I know why the formulas work. All right, moving on to the next phase here. Okay, let's see. The function p of t equals 110 e to the power models the population of a city in millions t years after 2010. As of today, consider the following 2 statements. The current population is 110 million. The population increases continuously by approximately 3.9% per year. This model supports. Okay, so for this one, that's what makes this question like a little funky, is we're doing this years later. All right, but if we think about this one, it's like a bit of a trick question. We look at this one, the current population. This Regents was, let me look at the date. That's why I'm like flipping around here. June 16, 2017. So t years after 2010. So when they say the current population, it was like as of that date. Like I know it's 2025 right now. I don't even know what's today's date. It's June 24, 2025. But when the test was happening, pretend we're in our time machine and like this is the date. Okay. So 8 years ago. Oh, wow, I was still in my 20s. Look at that. Okay. Yeah, I turned 30 in 2018. If you want to do the math and get my age. All right. So for this one, the current population, this was initial population. Okay, which would be in 2010. Because t is years after 2010. So the initial population is here. And the reason I know that is like, yeah, t equals 0 would be 0 years after 2010. So this would be like in 2010. And that would give us p of 0 equals 110 times e to the 0, which would just give us 110. And then, yes, the population of a city in millions. So it would be 110 million is the population of a city. That's kind of big for a city. I don't know. Where's the city? I feel like it's like, I don't know, some foreign galaxy. But whatever, we'll just go with it. I didn't really think that far. Okay, so this one, like as time goes on, like definitely not. I mean, even if we were to, let's see, go to the calculator and type this in. We've got 110 and then e to the 0.03 922 t like this. And in 2017, that would be t equals 7 years after 2010. So if I go to, at 7, see how I'm at 144.75? I'm no longer, at the starting population. So that's how I know like 1 is not true. All right, the current population, like t equals 7, like wouldn't be good. All right, the population increases continuously by this. That one works. So think of this formula, A equals PE to the RT. So if we look at this, we just match this stuff up. This tells us that R is equal to 0.03922, which is the same thing. This is roughly 3.9%, because 3.9% is the same thing as 3.9 out of 100, which is 0.039. Which matches the coefficient of t. So that's why this one's good, 2 only. All right, so A PERT. All right, rational equations. To solve this, Ren multiplied both sides by the least common denominator. Which statement is true? All right, well, 2 is an extraneous solution. 7 over 2. 0 and 2 are extraneous solutions. All right. Well, you know what? I'm just going to work it out the same way Ren did. So 2, let me change colors here. So 2x over x minus 2. I'm going to leave space. So let's see. Minus 11 over x, leave space, equals 8 over x squared minus 2x. And multiply by the least common denominator here. If you look, it's like we have x minus 2, we have x, and then x squared minus 2x is x times x minus 2. So the least common denominator is x squared minus 2x. But one thing I like to do with these questions is say what x cannot be. X cannot be 0, and also x cannot be 2. Because that would make the denominator 0 for one of these denominators, and that's no good. You can't have a 0 denominator. So now I multiply by this. I multiply by x squared minus 2x. However, x squared minus 2x is x times x minus 2. So instead of multiplying by x squared minus 2x, I want to multiply by x minus 2 all the way across. And then x times x minus 2 is x squared minus 2x. This one I'll write as is, so we can see these cancel completely. This one, the x's cancel, and then this one, the x minus 2's cancel. So then we get 2x times the leftover x is 2x squared minus 11 times x minus 2 equals 8. And then we got 2, I'll write it over here. We got 2x squared. Then you got minus 11x plus 22 equals 8. And now minus 8. And this gives you 2x squared minus 11x. And then we get plus 14 equals 0. All right, so we get to this part. And for this, I could use the AC method. So AC, so when you have ax squared plus bx plus c equals 0. AC is the product of the first and last number. First and last coefficient. So 2 times 14 is 28. And then our b value is negative 11. And then you look for two numbers that add to negative 11 and multiply to 28. And that would be negative 14. I was just joking. It would be negative 14 and 3 because that would make, what's it called, negative 42. It would be negative 7, negative 4. All right. So we'd have 2x squared minus 7x minus 4x plus 14 equals 0. Now we factor by grouping. So take out 2x and you got x minus 7. Take out minus 4. And, oh, what am I doing? I'm sorry. I'm like not on my A game right now. Let me just, we factor out x and we're left with 2x minus 7. Now, how did I know I messed up? Because when I went to factor out a greatest common factor here, it didn't match this. So this, the greatest common factor, I could take out a 2. But I'm going to take out a minus 2. So I get a matching binomial on the inside, and I get 2x minus 7. All right, because look, math, you'll make little missteps, and you'll be like, whoops. But if you could catch your nonsense, like that really helps. All right, so here, take out 2x minus 7, and then x minus 2 equals 0. So this one will give you a root of x equals 7 over 2. If you just set 2x minus 7 equal to 0. And this gives you x equals 2, but x equals 2 is an extraneous solution. Okay, x equals 2 is extraneous because we said in the beginning x cannot be 2. X equals 7 over 2 is not extraneous because it does not make a denominator 0. All right, 0 is not a solution, so it can't be extraneous. And it does have extraneous, so 4 is out. 1 is it. All right, f of 9 equals negative 2. Oh, these questions were like kind of exhausting. I'm feeling sluggish going through them. Like this was like sort of an exhausting Regents. We did 2 trig questions. I'm going to do one Regents practice, but I do have old ones saved. Go to my folder for old Regents. I've done a lot of them. So, sadly I won't have the live me talking and making cool commentary along the way, but oh, you're terrible on tests. Yeah, well, you know what? Just, you do your best. The more you enter the mix, test nerves are a real thing. learning how to conquer that fear is something. Just do your best to like breathe. Know that being anxious is always part of it. So at Michaela, that never goes away. That feeling of like, oh, I forgot everything. It will come back to you, like during the test. Like just you stay in the pocket, you stay patient. Some things may not come back or some things may stump you, but you just do the best you can. All right, let's see. So f of 9 equals -2. Which function can be used to generate the sequence this over here? All right. So how is this changing? Plus 0.75, it looks like. Maybe. This is like where my head goes. Like plus 0.75. That's what I'm thinking. So this one, it looks like, yeah, f of 1 is 8. F of 2 is -7.25. So, you know, for something like this, like we could just see like, all right, like let me just go through the answer choices and see which one is it. The problem here, though, if we look, is that f of 1 has to give us -8. And when we look at, let's see which answer choices could be. Like this one could be thrown away. I could see, because when I plug in 1 like this is not -8. So like that's how I know 1 is out. This one gives us -8. This one does. This one does not. See, if I plug in 1, this zeroes out, and then I get -0.75. So that's like where my head goes, is like, all right, let me eliminate some stuff first. And then like now, if I was going to guess, I have a 50-50 chance of guessing. But the other way would just be then from here to just type these in the calculator. Okay, so type in the 2 remaining ones in the calculator. Or you could type in all 4 and see which one. All right, so negative, make sure you use that button. -8 minus 0.75. And then x minus 1. Okay, second graph, I go to the table. First is -8. But look at this. Second is not -7.25. So right away, 2 is out. It has to be choice 3. But let's hope choice 3 is it. -8.75. And the reason being, the list is increasing. This one is decreasing. So that's why 2 is definitely out. So plus 0.75x. Then we go to the table. And then 1 brings us to -8. And then we get, we get 2 gives us this. The third term is -6.5. The ninth term gives us -2. So 3. 3 is it. Calculator saves the day. All right. So the function f of x represents a damped sound wave function. Damped. Maybe there's a. I'm gonna look up like Google pronounce later. Okay. How do you say this, Google? But what is the average rate of change for this function on the interval -7 to 7 to the nearest hundredth? So that one we're doing f of 7 minus f of -7 over 7 minus -7. We're really just finding the slope. Okay, remember, average rate of change of f on AB is f of b minus f of a over b minus a. So you're just finding the slope. Okay, that's it. Just find the slope. So I go to the y equals, and I type this whole mess in. 2 to the power -0.25x times sine of pi over 2x. Alpha y equals enter, makes blank fractions. And then we got pi over 2 times the x. All right, awesome. And now I could go to the table like this and just copy down the y value for 7 and also for -7. Like that's fine. A fancy way to do this, you ready? So f of 7. I wrote f of x in y1. So remember that, y1. I make my fraction, alpha y equals enter. I press alpha trace y1. Parentheses 7. This will tell the calculator, hey, what's f of 7? Because y1 is f of x. Minus f of -7. I can press alpha trace y1 and then put -7 in parentheses. I'll pretend I don't know 7 minus -7 is going to give us +14. And it gives us this. Cool little trick. So the average rate of change is not. Oh, you know what happened? Oh, good thing they didn't. So what happened? Before I changed the calculator back to degrees. Oof, that would have been tragic. Radians all the way. So now, don't worry, not a massive time waster. They should have a. That would be mean if they put a degree answer. I would have got there, but it's all right. You don't have to get. I mean, look, if you get 100 on the Regents, you get bragging rights for a while. I have some coworkers who still brag about their Regent scores, even in their 30s and 40s and 50s, 60s even. So you get bragging rights for a while, but it's all right. You don't need to get 100 for bragging rights. And it's not a sprint. It's a marathon. So even if you don't do amazing, you can still be amazing a year later or 5 years later or 10 years later. Cool. So now we just say, this one, 21, should be choice C. This is like LOL, degrees. All right, don't be in degrees. Be in radians. Radians all the way. Except if you want to check, like, I only switched it to degrees so we could see what that angle was before. All right, this one I thought was cruel. All right, so this one is like evil a bit. A little evil. Because it's like, read carefully. Okay, so Mallory wants to buy a new window air conditioning unit. The cost for the unit is this, $329.99. If she plans to run the unit 3 months out of the year for an annual operating cost of $108.78, which function models the cost per year over the lifetime of the unit C of N in terms of the number of years N that she owns the air conditioner? Oof. All right, so this one, like, honestly, I had to read it a few times because it was like, what is going on? So the cost C of N of the unit is $329.99. That shows up in every answer choice. So, like, all right, let's start with this. $329.99. That's the cost of the unit. She plans to run the unit 3 months out of the year for an annual operating cost of this. N is the number of years. So the plus 108.78 times N is like how much it cost per year. Now, this one is evil. This is the evil part. 3 months out of the year. Because, like, it's tempting to multiply something by 3. But they're telling us if she plans to run the unit 3 months out of the year for an annual operating cost of this. This is really like how much it costs to run per year. This is a distraction to tempt you to multiply things by 3. But they're asking us which function models the cost per year over the lifetime of the unit. Okay, over the lifetime of the unit. Okay, C of N in terms of the number of years that she owns the air conditioner. So at the end, we have to divide this by N because we want a function that models the cost per year over the lifetime of the unit. So, like, how long does she own it? N represents how much time she owns it. So we have to divide by N at the end, which is like, kind of like, all right, you got me. And that 3 month detail is also kind of cruel. So 22 is actually choice 3. All right. So this one, divide. This one was a little mean. So x to the third plus 2x squared. And we're dividing into negative 3x squared minus 5x and then plus 2. The math that I'm doing in my brain for this is I'm dividing the leading terms. So I'm doing this divided by this. Negative 3x squared over x to the third is equal to negative 3 over x, which is the same thing as negative 3x to the negative first. So that goes here, negative 3x to the negative first. And then I multiply. So I do negative 3x to the negative first times this is negative 3x squared. And then negative 3x to the negative 1 times 2x squared. I do, let's see, negative 3 times 2 makes negative 6. And then I multiply x to the second by x to the negative first. And x to the second times x to the negative first is x to the first power. Now when you subtract here, the minus goes through like this. So the minus goes through. So when we subtract this, we're actually a shortcut. We could just change the sign of everything. So these wipe out, and then negative 5x plus 6x makes 1x. And then I start the process all over again. So I do, next I have x over x squared. I'm doing, what's it called here? Oh, I'm sorry, let me start that over. X over x to the third equals 1 over x squared, which equals x to the negative 2. Okay, so what you're doing is you always like start by going, you do this divided by the leading term. Okay, so you see how I did like negative 3x squared divided by the leading term? And then I do the remainder divided by the leading term. And I just keep doing this until the end. So now, see how we got x to the negative 2. So that's plus x to the negative 2. And now I multiply. X to the negative 2 times x to the third is x. I could bring down this remainder here, plus 2. And now I do x to the negative 2 times 2x squared. And 2x squared times x to the negative 2, or I could say 1 over x squared, just makes 2. Okay, so that's going to give us plus 2. And now when we subtract, I subtract this, we're going to have 0 remainder. So this is our quotient. Okay, the negative 3x to the negative 1 plus x to the negative 2. Choice 4. Oof. Or, you ready? You're like, no, thank you. Yeah, that was like pretty nasty algebra. But I can't like not show you the algebra. If I just only show calculator magic the whole way, I feel like I'm doing you all a disservice. You know, it's like poor leadership to just be like, use the calculator. Who cares? I have to, lead by example. All right, and I will do that my whole career. Okay. So here's the question, and then you could just go through the answers. You ready? And then plus x to the negative 2. You graph, and they overlap. So 4. All right. Oh, don't hate. All right. So this one, we've got a good formula for this one is the sum of a, geometric series. You've got a1 minus a1r to the n over 1 minus r. All right, the sum of the first n terms. Jasmine decides to put $100 in a savings account each month. The account pays 3% annual interest compounded monthly. How much money S will Jasmine have after 1 year? All right, so this one, it helps to know A equals P times 1 plus R over N to the NT power. All right, so here, 3%, R equals 3%, is 0.03. So, this starts off here where, she puts in $100. So, like, start of the question here, like, all right, 100. And then, like, that 100, like, if we just follow this one, I'll keep tracking this, will grow according to, all right, 100 times 1 point. And then for this one, we are doing R divided by N is 12. So compounded monthly means N equals 12. So I could start to modify this and say, all right, A equals, 100 times 1 point. If I do 0.03 divided by 12, I promise you we're going to get 0.025. Like this. And then it's to the 12, T power, where in this case here, like T is the time, and like in our years. But like as we go through this here, like what I start to see is this is just building up like this. So we have 0.025 is like, let's say by the second month. In the second month, the first 100 matures this much. Okay, but then in the third month, it's like, all right, 100 plus this one, and then I'll stop tracking it, matures like this. But then the one in yellow matures twice like this. So I don't know if we could all kind of follow what's going on, because every month she's adding another 100. Okay, so these, like this is the idea. So then what happens by month 12? Okay, after 1 year, or, you know, this is, I'm going to write this in months. Well, after 12 months, this is 100 plus, you know, we have 100, 1.0025, plus we get all the way to the end. But see, when we had S sub 3, we stopped at 2. So S sub 12 is going to stop at 11. So we'd have like the 100 times 1.0025 to the 10, but then plus 100, 1.0025 to the 11. Okay, and for this, see, that would be the last one that we tracked from the beginning. And then this would be the second to last one that we're tracking. So this is where, like, really what we're finding is the sum of a geometric series, you know, a finite one. And then it's really just like, all right, S sub 12 is equal to the first term minus the first term times, you know, except here, our, like, ignore this R for now. The multiplier, or like the common ratio, I should say, common ratio. The common ratio is 1.0025. So that's what's going to go here. All right, like this is kind of a trap, because it's not accounting for the monthly compounding here. So just be on the lookout for that. And then we divide by, we have 1 minus R, 1 minus 1.0025. Okay, so 24 is actually choice 2. All right, so that's the idea. So a sneaky question. This one was a little evil. All right, part 2. 2 credits each, 8 questions. Now we got to show work. Can't just do calculator magic. R of 2. Well, I mean, this one we could just plug in. Let's see. So we got 2 to the third minus 4 times 2 squared plus 4 times 2, and then minus 6. So R of 2. This I could just use the calculator. It's going to give us 8 minus, don't forget Aunt Sally, if I do this without a calculator. That's going to give us 4 times 4 is 16, and then plus 8 minus 6. And this gives us, we have negative 8 plus 8 minus 6. And these just wipe out and give you negative 6. Okay, so this works out to negative 6. All right, or once again, just go in the calculator and just like type this in. What does your answer tell you about x minus 2 as a factor of r of x? Well, x minus 2 is not a factor because r of 2 is not a root. Or x equals 2 is not a root. So r of 2, I'll just say, equals negative 6, which is not 0. So x equals 2 is not a root of r of x. Therefore, 3 dots means therefore, I promise. Everyone should write this way. Therefore, x minus 2 is not a factor of r of x. Okay, if r of 2 was equal to 0, r of 2 equals 0 means x equals 2 is a root, which means x minus 2 is a factor. My bad, algebra 3, I went too hard. I'm sorry. My bad. I didn't mean to like overcook the last question. To be honest, everybody, like full transparency here, I have never taught algebra 2 as a Regents class. Like, I do these videos because I like to, like, when I'm working with I teach geometry and AP Calculus BC. So when I get my AP Calc kids, I like try to know where they came from. So that's why I go through these regions. It's just like, and that's why I've been doing like 3 through 8. Yeah, so one more time at Amina, the root. So this is a good theorem to know. So something like know this. So know this. If x equals c is a root of f of x, which like this means like, you know, f of c is equal to 0, then x minus c is a factor of f of x. Okay, it's a big idea. Like, this is a good idea to know. This is called like the remainder theorem. Yeah, remainder theorem. So thank you, Kevin Lee. I appreciate you mentioning that. So, all right. Oh, they said bears because my like theme is bears. So the weight of a bag of pears at a local market averages 8 pounds. Oh, all right. So normal CDF. Someone asked about that. All right. So the weight of, so the average. So the average. I'll use the calculator symbols. Do they still use X bar? So this is average. So the average is 8. The standard deviation, is it this one? I'm going to see in the calculator in a moment. So this is like standard deviation. The weight of all the bags, normal distribution. All right. So if the average is 8, that's like 0 standard deviations away. Like the average is, yeah, like at the top here. And then the standard deviation, like 1 would send us to 8.5. I would go plus 1 standard deviation. If I went minus 1, that would be 7.5. If I went forward 2, that would be plus another 0.5 is 9. And then this would bring me to 7. Okay, so when they say the actual question is determine what percentage of bags to the nearest integer weighed less than 8.25. So 8.25 is like kind of like somewhere here and then back. All right, so I mean, yeah, like this one, it's like more than 50, but like in that range. But this is where the calculator comes in. All right, so you ready? Calculator. You press second vars. So let me clear this. Go back to the main screen. Second vars, normal CDF. The lower, okay, is 0. All right, we're going to go, normal CDF. The lower is going to be 0. The upper, we want to say like at most, so less than 8.25 means the upper is going to be 8.25. We don't want to go past that. We want to be less than that. All right, and now this one here is the average, is 8. And then this is the standard deviation, 0.5. Oh, so they go with this symbol instead. Because in the Algebra 1, they use the X bar. All right, you get this, and you get this. All righty. So for this one, honestly, the only work I'm going to show, I wouldn't just write the answer. This is the work I'm showing. I'm just going to write this. I'm going to say normal CDF 0, comma, 8.25, comma, 8, comma, 0.5, and then close the parentheses. And then say equals this. And I write down a few things. But then you have to know like percent, what percentage? Percent, you should go this times 100. Okay, which moves the decimal to the right twice. And then you throw on your percent. Okay, but they said to the nearest integer. So here we would just say 69%. That's it. So, yeah, that's that. All right, moving on, 27. Am I blocking? Let's see. I am. All right, factor over the set of integers, over the set of integers, factor this expression completely. So grouping, we take out x squared, and you're left with 4x minus 1. And then we take out greatest common factor here, which is 4, and we're left with 4x minus 1. If you can't do that math in your head, just know like what I'm doing is I'm taking the greatest common factor and I'm dividing each term there by that. So 16x divided by 4 is 4x, and 4 divided by 4 is 1. That's going in the parentheses, like this. So now we take out this, 4x minus 1 times x squared plus 4. We are over the set of integers. So don't start finding like, some people might go like extra, but don't do this. X squared plus 4, they might be like, ooh, like x plus 2i, x minus 2i, but like please don't do that. They said over the set of integers. So then all we have to do is stop here. All right. Cool. Ooh, look at this one. All right. So let me just take a sip. Let's see how many people we have on here. Well, there's 224 of you right now. How awesome. Oh, let me see. So, Vin, if I had a question and it was saying in a free response question and it asked us for you to express an A plus BI form, why on the model response set the answer has plus or minus? Yeah, those are not like super strict. So good question. Yeah, Fortnite sweaty kid. Nice to see you again. I know this is like 3 years in a row now that we're working together, so I'm always happy to see you on. But yeah, A plus BI, when you have something like, let's say 7 minus 5i, I mean, like technically you could say like 7 plus like negative 5i like this. But it's just like kind of like, honestly, I believe they give you the full credit if you write it like this. If you want to say like, yeah, like 7 plus negative 5i, and you put the negative 5 like this in parentheses, like, yeah, technically like that's like more plus BI form, but it's, they're like pretty okay. I would hope either way. That seems like really petty if they don't do that. But yeah. Oh, no, I'm sorry. Am I going too fast here? We're an hour and 51 in. You do get 3 hours to take the Regents. So I want to try to finish this before 3 hours. But my bad at top it all. Yeah, get that hundo. Hope you get that hundo. I'm proud. You're asking the right questions. All right. So here, the graph below represents the height above the ground, h in inches, of a point on a triathlete's bike wheel during a training ride in terms of time, t in seconds. Identify the period of the graph and describe what the period represents in the context. Okay, so here they said that the graph represents the height above the ground, h in inches, of a point on the triathlete's bike wheel. So if we look here, like, let's say this point here is at the top, is 26 inches above the ground. Okay, so this would be like, all right, 26 inches above the ground is here, like this, like relative to this. Then what's going on here is like as this thing turns, it's going to go down to 0, and then it's going to go back up. Okay, so a full cycle, it goes down and it goes up. So the period is how long it takes to complete a full cycle. So the period is equal to 2/3 of a second. Now, what does the period represent in the context? That's how long it takes the wheel to make one full rotation. Okay, because think about it. As it rotates, like the height of this point goes down to 0, and then it goes back up to 26. So it's like at 26, it goes down to 0 and then back up. So what does it represent in this context? The period, the wheel takes 2/3. We could say like 2/3 seconds to make one full rotation. Okay, or I can even say one complete rotation. Full is fine. Either way. Okay, it takes 2/3 seconds to make one full rotation. All right, so that's what it's standing for. Cool. All right, graph this on the set of axes below. And you're going up to, you're going up to 400, and you're going out to 10. All right, so this kind of question, I just type. So y equals 400. Annuities and mortgages, those, you honestly, they just give you a formula and just take your time plugging in. Like those are just kind of annoying. But just plug in carefully. It's like kind of like playing the game Operation. You can't rush. You got to just take it easy. All right. So out to 10, up to 400. So let's see. Wait, what's going on with this? Oh, because it's dropping. All right. So for these, honestly, it's like not the worst idea. I do personally like to write down the table values like on the side somewhere. Although if we look at the rubric, let me look at the rubric. So this is question 29. A correct graph is drawn. If you make one computational or graphing error, you lose one. One conceptual error, you lose one. So just like, I don't know, I guess you could just plot this carefully. But I like to write the table because like then I feel like the graders are, you know, they're people. And not like they'll get distracted, but they're like, oh, cool, like this kid told me what they're trying to do. And then they're like more likely to just give you the full credit, I believe. Okay, so like that's just my take. Because, you know, when you want to hear about the teacher side, you're grading the same question for like 2 days straight. So it gets pretty tiring to, you know, grade the stuff. And when you're grading it, it's just like, all right, it's like over and over. When it like looks good, like sometimes I bet there's like at least one where a teacher will give it full credit and maybe the kid is off by like, you know, a little space. But like stuff like this, like you write this down and they're like, oh, cool. Like this kid like plotted these points. And, you know, I'll write even like 50.9 even. I'll just round that from 897. And then this is like at 7, I'm at like 35.1. At 8, we're at 23.7. At 9, we're at 15.459. And then 10 brings us to 9.5. And then, you know, I just plot these carefully. It looks like we're counting by 20s. Let's see, 20, 40, 60, 80. Yep. So 20, 40, 60, 80, 100. And then this would be 120, 140, 160, 180, 200. 1, 2, 3, 4, 5. That'd be 300. And then 320, 340, 360, 380, 400. So 394 at 0 is like basically at 400. Okay. And then 283 would be like over here. So see how this would be 280? So 283 is like a smidge above, like not that much more. This is like almost 200 at 2. It looks like they're skipping here by 2. So like, you know, every 2 is jumping 1. So 5, and then 6, 7, 8, 9, 10. So when we get to 2, we're at 202. So that's like over here. This is like, yeah, this is kind of annoying to graph this one. 3 is at 144. So a little over 140. Okay, so like here. And then 4 is at 103. So like a little over 100. Okay, 5 is at 72 and change. So that's like a little bit above the halfway point. Because 70 is in between 80 and 60. So a little above that. 6 is at 50.9. So basically halfway. Then we got like 35-ish. So the halfway would be 30, and then like half of that, like 3/4 would be 35. 8 is a little above 20. And then 9 is at 15. And then 10 is like, yeah, over here. So then carefully, I'm just going to go like one piece at a time. I'm going like, all right, down, like this. Yeah, connect a little more like that. All right, there's our graph. It goes to the end of the grid. You don't have to put arrows when you go from the end of the grid to the other end of the grid. Okay, so that's just something to know. So if you go end to end, you're good. All right, solve algebraically for this. So if I don't do this algebraically, I use a calculator, I get half credit. So just remember that. But for full credit, I got to do this algebraically. So I'm going to go minus x. And now that gives us radical x minus 4. X minus x cancels and equals this. All right. You know what? Maybe what I'll do is I'll rewrite the question underneath so that we can remember the original. Because we have to check for extraneous solutions. So we got this equals 6. These wipe out and it gives us this. And now from this step, we could square both sides. And now radical x minus 4 times itself is just x minus 4. And this, I'm going to call this a side quest. I'll do over here. We're doing 6 minus x times itself. 6 times 6 is 36. Then you got minus 6x minus another 6x plus x squared. That makes this. All right. So the right side is 36 minus 12x plus x squared. And from here, what we want to do is we want to get everything to equal 0. So we could potentially factor, or we could use the quadratic formula, whichever one makes more sense here. So I'm going to move everything over. So minus x on both sides, and then plus 4. So this is gone, and we have 0 equals 40. Minus 12 minus 1 gives us minus 13, and then plus x squared. So now this I'll write over here. This is x squared minus 13x plus 40 equals 0. This factors to x minus 8, x minus 5. Because negative 8 plus negative 5 is negative 13. When you multiply those, you get positive 40. So our temporary roots are x equals 8 and x equals 5. But we have to check for extraneous. So when you check, I'll do that over here. X equals 8 gives you square root of 8 minus 4 plus 8 equals 6. Which this gives you square root of 4 is 2 plus 8 equals 6. This is not true. Okay, so we reject. Okay, reject x equals 8. However, x equals 5 should be good. X equals 5 gives us square root of 5 minus 4 plus x is 5 equals 6. This gives us 1 plus 5 is 6, which is true. So just one answer. X equals 5. Cool. Let me check on the chat. How we all doing? All right, let's see. So moving on. Okay, I'm just trying to follow the chat too. All right, so here, write this as a single term with a rational exponent. So remember from before, a to the b over c equals the c root of a to the b power. So this is the same thing as c power 1 power 1. Just know when there's no number written in front like this, there's an invisible 2. Like square root of 9 is really like the 2 root of 9. So just, yeah, also know that. So this becomes x to the 1/3 times x to the 1/2, which now becomes x to the 1/3 plus 1/2. And let's say you like low key don't know how to do fraction math, enter. It's 5/6. Okay, so this is x to the 5/6 power, and that's our answer. All right, this data question was like a little annoying, but you know, just think carefully here. Confidence intervals, yes, for simulations. I don't know if this one has, let me see, does this one have? Oh, this has one of those annoying mortgage questions. Oh, this has a simulation question, not to worry. All right, we're getting there. Oh, 2:03. All right, yeah, we're 2 hours in. So data collected about jogging from students with 2 older siblings are shown in the table below. And for this, using these data, determine whether a student with 2 older siblings is more likely to jog if one sibling jogs or if both siblings jog. Justify your answer. All right, so for this one, I always like to find total. All right, so I like to find the total. Like that's just like something I like to find as I do these. Okay, so I mean, I don't have to write it out here, but I just like to add those up. So with this, if I add this plus this plus this, just for the sake of time, I promise you I get 4,371. If I add this plus this plus this, I get 1,004. In this column, if I add these two, I get 1,356. If I add these two, I get 22 and then 39. If I add these two, I get 1,780. And now a little check at the end is like when I add these three, I get 5,375. And that's the same thing as when I add these two. Okay, so it all checks out. I just always like to find my stuff first, right? And that's, like what's going to get us there. So using these data, determine whether a student with two older siblings is more likely to jog if one sibling jogs or if both siblings jog. So this one, if we, look here, I'm going to find this probability that a student jogs given that they have both siblings jogging. Okay, so I'm going to say, probability, that a student jogs, given that both siblings jog equals. So for this one, we're going to calculate or look at the probability that a student jogs given both siblings jog or if like only one. All right, that's what they're saying here. Determine whether a student with two older siblings is more likely to jog if one or both jog. So let's look here. If both jog, so that's this column here. And then we look over here. Probability that a student jogs. Well, we're going to be looking at how many students in this column jog 400 out of the total 1,780. Okay, so we're calculating this probability. All right, so once again, this is the students where both of their older siblings jog. And 1,380 of them don't jog, even though both of their older siblings jog. But 400 of them do. So we got to consider the total for this conditional probability, okay? Because this is restricted right now to both siblings jogging. And if we work this one out, this is 0.225. Okay, now I'm going to calculate the probability that a student jogs given that one sibling jogs equals, and we look here. So this is for the one sibling jogging condition here. All right, we're restricted to this population. Well, the number of students that jog in this category is 416. Okay, and we're out of a total of 2239. And when you calculate this one, this simplifies to 0.186. But if you look at this probability is higher than this one. And this is from the students who they have two older siblings that jog. And this one is the one sibling jogs. So using these data, determine whether a student with two older siblings is more likely to jog if one sibling jogs or if both siblings jog. Students are more likely to jog when both siblings jog. Okay. So I'll just summarize this here. Determine whether a student with two older siblings is more likely to jog if one or both siblings jog. This is the justification. So we could just say here, students are more likely to jog when both siblings jog. Okay, so I'm just summarizing what we got here. That's it. For these though, if I had with that particular walkthrough, what I always tell students to do is to go to the model responses. So let me actually open it up for question 32. So we could just kind of see smart ways of studying this up. Granted, the test is tomorrow, but still, this resource is pretty good to look at. So I usually like to show this. I'll put this in the chat. Okay, so the model responses, and I'm going to pull this up. I'll just say go to page 36. Okay, so 36. So if you go to 36, you'll be able to follow what I'm looking at here. And you look, oh, I like that notation more right away. So yeah, probability that a student jogs and given that one sibling jogs. And for this one, just work this out. And you see how we got the 0.19, same as me, and then the 0.22. So a student is more likely to jog if both siblings jog. And this is like, they wrote because, or like they're just capturing their data, but like the justification is here. That's just it. They point to this one, hey, more likely. That's it. So yeah, I mean, there's probably like cleaner ways of getting this. They made a computational error in calculating the probability of jogging given that one jogs. So yeah, probably abbreviating would have been nicer to use the notation, but I don't know. It just like, this was like a really long like title. So it's nice when they introduce like that notation for you and they're like, hey, say it this way. But otherwise just like, meh, it's whatever. But that's how I would use that stuff too. Kramer's rule. Wow. All right. If you use Kramer's rule, that's really impressive. If you know that. So Kramer's rule is fine. You could use Kramer's rule. But just like write. All right. So do this. Do me a favor. If you use something wacky like Kramer's rule, let them know, like write the name of it above. Because what happens is like sometimes the graders don't know like what that rule is. And then they're like, hey, like, what did you do? And then like they have to go searching for it. And it takes forever to grade your paper. But Kramer's rule is legit. So great that you know it. So 4 questions, 4 credits each. So here we go. All right. So moving on here. We have to solve algebraically for x, y, and z. So this elimination all the way. I personally like to name these like equation 1, call this equation 2, and equation 3. Because when I do this, I like to like say like, oh, I'm going to add these 2 equations together and I'm going to add like these 2 equations together. So, you know, my first glance at this, I want to see like, what did I do in the past here? There was like a different way I had done this. I'm trying to think of like the easiest like way through this where it'll work out nice. I mean, maybe like it's better like I just do this completely organically. But oh yeah, okay. So the first one I attempted here was like, all right, let me eliminate x because I saw like x and negative x. So like these seem like the thing to do. So I say like, all right, I'm gonna do. I wrote it out like this, like equation 1 plus equation 3. And if I add equation 1 and equation 3, see I'm doing x plus negative x cancels out. So like that's math that I'm doing in my head. It's like x plus y plus z equals 1. And then negative x plus 3y minus 5z equals 11. I mean, you know what? Whatever. I'll just write it out. X plus y plus z equals 1. And then negative x plus 3y minus 5z equals 11. When we add these together, we get 4y. And then z minus 5z is minus 4z equals 12. Okay, so that brings us here. And then I also chose to do equation 2. I'm sorry, yeah, equation 2 plus 2 times equation 3. All right, because if I double equation 3, then the 2x and minus 2x cancel. So you see equation 2 is just 2x plus 4y plus 6z equals 2. And then if I double the bottom, I get minus 2x. 2 times 3y is 6y. 2 times negative 5 is negative 10, so I get negative 10z equals 22. And when I add these together, I get 10y minus 4z equals 24. Okay, and that brings me here. So then these combine. And what's nice about these, like once you solve one, it's like it kind of just unravels. So I bring these together and I have 4y minus 4z equals 12. And then for this one, there's a few things I could do, but I'm going to say like also like maybe like times negative 1. So I bring that up times negative 1 and that's going to give a negative 10y, a plus 4z, and a minus 24. All right, so now when I add these, 4y plus negative 10y is negative 6y. These cancel. And then 12 minus 24 is negative 12. And then you just divide everything by negative 6. and y is equal to 2. And once I find out what y is, everything else unravels. Okay, the rest just collapses now. Because now I could take this and say like, all right, y equals 2, comma, and like 4y minus 4z equals 12 becomes, 4 times 2. Oh, that looks, see, 2 and z look alike. So this is 2, and this is like, I think what they do for z is like sometimes they'll do this. They'll put like a little strike through. Equals 12. So now this becomes 8 minus 4z equals 12. Subtract 8, and you get negative 4z equals minus 8 gives you 4. So then z is equal to negative 1. And now that we have z, we can find x. Okay, so now I'll go back to, let's say, equation 1. So equation 1, I have x plus y is equal to 2 plus z is equal to negative 1 equals 1. And then this gives us x plus 1 equals 1, which gives us x equals 0. And that's the last one. Okay? Cool. So that's 33. Awesome. All right. Oh, sorry. It's like mosquito season again. Starting to get, I did get hit today. All right. I think you could store a number. Yeah, storing numbers I did go over before. All right, so this is that classic annoying mortgage stuff. So Jim is buying a vacation home. Oh, nice that he's able to buy one for 172. Oh, this is an old Regents. This is expensive now. For 172,600 near his favorite southern beach. The formula to compute a mortgage payment is given here, where P is the principal amount of the loan. So that's like how much you owe. R is the monthly interest rate. N is the number of monthly payments. And Jim's bank offers him an interest rate of 0.305%. That is so misleading. Just so you know, like real life, like right now, it's like roughly 7% in that neighborhood. So this is misleading. Okay. It's way harder. All right. So just want to point that out. I feel like that's like false advertising. They should at least keep it real. Like, don't pretend like it's this nice. All right. With no down payment. So no down payment means he owes all of it. Because let's say it was like with a 10,000. If he was putting 10,000 down, then he would owe like 162,600. He would like pay 10,000 off. But nothing is being subtracted. Okay? So that means like P is going to be equal to, the like full amount here. All right, so I'll just start defining variables. So wait, sorry, I just got a mosquito bite on my calf. It got me. All right. I know you're not supposed to scratch, but it's like sometimes you can't not. All right, so P equals 172,600. And let's see, M is the monthly, mortgage payment. And let's see, R, they gave him a interest rate of 0.305%, which R is equal to 0.305 over 100, which is 0.00305. Okay, so that's going to be R. So we have this, and we have this. And then we also need to know 15 years. Okay, so 15-year mortgage. N is the number of monthly payments. So capital N is going to be equal to 15 years, but there's 12 months a year. Okay, so 15 times 12, we work that out, and that's going to equal 180. All right, so there's 180 monthly, or I say like months of payments that he has to make. Okay, so like that's where like the 180 is coming from. So capital N is equal to 180. And is there anything else? Now we just plug in. Okay, so M equals 172,600. Okay, times fraction bar, and let me just move this over. So times this. So now we have R. Oh, they didn't make this nice at all. Times, I'm going to say 1 plus 0. 00305 is 1.00305. To the n is 180 power over 1.00305 to the 180 and then minus 1. Okay, so that's what we're going to work out. And we're going to the nearest dollar. All right. So 172, 600 times alpha y equals enter. And now just don't mess this part up. 1.00305 to the 180. Yeah, with these, it's like just take your time setting them up and don't make a typo. That's like my whole mantra. Don't make a typo. And also make sure your answer is reasonable at the end. All right, because if you get like a monthly payment of like $10 trillion, like that's probably not real. So this is going to be 1247. All right, so 1247.49, so we round down. So M is 1247. Cool. Let me see. Vin, what do I have to do if I have a margin of error question and it asks you to describe what does it mean in a situation or simulation that's on a normal distribution? Yeah, if it's on a normal distribution, then you're really just hanging out in the plus or minus 95. Like that's like honestly the main idea for all of those is if they're asking you for like margin of error, like you're able to be like within 95% of the like, you know, like in the normal distribution. So like you have a pretty large like margin of error. If you're like more than 2 standard deviations away or less, like, you know, minus away, then that's like, oh no. But yeah, otherwise like they're pretty like that's like just the main idea as it was like put in the chat. There's really no like I gotcha questions for simulations. Like those are just kind of annoying enough. The only I gotcha I ever saw was like which one what's it called? Like, you know, if they want to say like, is this like not okay? Or like, is this like not okay? And it's like, oh, is it okay? Like sometimes they use like double negatives and I'm like, why'd you do that? Just like say it straightforward. So sometimes like just decoding what they're asking for is like kind of annoying. But yeah. All right, let's see. Algebraically determine and state the down payment rounded to the nearest dollar that Jim needs to make his mortgage payment $1,100. Oof. All right, so this one, we're solving for P where we want M to be 1100. So like this is what we want like to be M. So we want M to be 1100. We want to know what would P have to be if same stuff as before. So R is 0.00305 and we're multiplying by 1 plus R to the n power is 180. And then over 1.00305. Okay. Oof. This one's like, all right, why this is like, it's not as bad as it looks. All right, you ready? This still is algebra, so I'm just going to do it. So really all I'm going to do, see how it's like now instead of 172,600 times this, it's just P times this. So I'm going to like, I don't feel like retyping all that. So I'm going to go all the way to the left and I'm going to delete this. Delete. I just want to know, what is that equal to? It's equal to this. So do you all see that? Like all I did was that number. Okay, and let me just see. Make sure that it's... Okay, so this is a little insane, but I'm just going to go for it. Because they didn't say, like they said algebraically, but it's like, all right, you asked for it. So I could just say now 1100 equals P times, and now I have 0.00305 0.00722765558. So I just took that entire mess and typed it in the calculator. All right, so then I could just say, all right, well then move this over. So you asked for the algebra, I'm going to do it. Now I just divide by that number. So I'm dividing by this on both sides. So there's algebra. It's technically algebra. I mean, I wouldn't like start like multiply by this, divide by this. Just simplify that and then divide. That counts as algebra. And now P equals, and just divide 1100 by that. All right, so now 1100. Oops, 1100 divided by this. And what that gives you is now this value here. To the nearest dollar, though. So hang on a second. So to the nearest dollar, that's 152,193. So that's P equals, once again, 152,193. The problem, though, is this. They're not asking you what is the principal. They're saying what is the down payment. Okay, so solve for the down payment. So you have to now find the difference between this and the original price. Okay, so the down payment is equal to the 172,600. That's the original price minus whatever money would be left like owed. Okay, like for 1,100 a month mortgage, that means you need to owe that much money. So if you want to know your down payment, you do the total price of the home minus how much you owe, and that's how much money you would have put down. All right, so let me just do that. 172,600 minus 152,193, 20,407. All right, cool. I hope you all pass. I really do. Want to borrow some aura and wisdom. It's really, yeah, just do the work. That's it. All right. All right, question 35. So let's see. Question 35, we're going to graph this and use an appropriate scale to include both intercepts. All right, 35. Oh, yeah, we have 3 questions left. Okay, so that's it. All right. So moving on, let's see. So calculator. All right, let's see. Y equals. So we got log base is option A. So we got log base 2 of x plus 3 and then minus 5. All right. So we press graph. Now look, the table matters a lot. All right, the table is very important. Set graph, I go to the table. And, the error starts at -3. A little trick, your vertical asymptote is when the inside of the log is 0. All right, so, like if I jot some of this stuff down here, like I'm going to need these values. And then, let's see, maybe some of these are useful too. So I'll just take, what I can here. Is there a way to like send that backwards? I mean, whatever. I could just copy down some significant values here, but we need to scale this so that we include both intercepts. All right. So let's see. So I go, let me just scroll down. Yeah, so both intercepts means like we're going to have to go out like pretty far. Like this is one of those also I got you questions. All right. Let's see. All right. So I'm going to write this down. So we got X and then Y. Yeah, no, this one is like kind of annoying. I'm going to show you a little trick though. The vertical asymptote occurs when the inside of the log equals 0. So the vertical asymptote is at X equals -3. All right, so just pointing that out. Now, what's annoying is use an appropriate scale to include both intercepts. We don't hit 0 until 29. So that means like we should be going out to like 30. All right. So I'm just pointing that out. All right, let me see. How do we change the base? Oh, on TI-83, honestly, I would be making it up. I haven't used a TI-83 in forever. I'm not gonna lie. I mean, if you just like, that would be like good use of AI. You're just like, hey, how do I do that? Like then I would look that up. But off the top of my head, I'm just gonna be honest, I don't know. Okay, so this is the vertical asymptote at -3 and then 0. And then we have, let's say 3, 6, 9, 12, 15, 18, 21, 24, 27, and then 30. All right, and the values I would write down is, I would say like, all right, -2, -5, -1, -4. And then we have, let's say 1, -3, 5, -2, and then we have 13, -1. And then we don't hit 0 until 29. All right, but those are the values I would jot down, the integer ones. Because those are the ones that are like, the ones we could like kind of like plot reasonably. And that's what I'm going to do. All right, so we'll get this stuff down here like this. And then go from here. So at -1, I'm sorry, -2, we're at -5. So this I'll count by ones. I'll go like, all right, 1, 2, 3, 4, 5. So this would be 1, 2, 3, 4, 5. And then this would be, -1, -2, -3, and so on. So -2, -5 puts us down here. So let's say this is at -5. This one's at -4. And then -1 puts us at -4. So they kind of pick like a really bad one here, but whatever. That's how they're rolling. All right. And then 1, we're at -3. Like this. 5, we're at -2. 13, we're at -1. And then by 29, we hit 0. Okay, so this is our vertical asymptote like this. And I'll say like, yeah, it goes through like that. All right, so both of our intercepts. So we have an intercept here, and we have an intercept here at 29, 0. So considering all that, if we look, describe the behavior of a given function. Describe the behavior of the given function as x approaches -3 and as x approaches +infinity. Well, technically we're approaching -3 from the left. So as x approaches -3, the function, okay, y is approaching -infinity. Okay, so you could just say that as x approaches -3, y approaches -infinity. And as x approaches infinity, y is also approaching infinity. Because as x approaches -3, you see how the graph is dropping down. But as x goes on, the y values are going up. Slowly, but they're going up. Okay? All right. So, going on here. All right. Let's see. All right, let's see. Cool. All right. So 36. We will take a look. So simulation. Classic simulation question. And we'll take a look here. 36. Charlie's automotive dealership is considering implementing a new check-in procedure for customers who are bringing their vehicles for routine maintenance. The dealership will launch the procedure if 50% or more of customers give the new procedure a favorable rating when compared to the current procedure. The dealership devises a simulation based on the minimal requirement that 50% of customers prefer the new procedure. Each dot on the graph below represents the proportion of customers who preferred the new check-in procedure, each of sample size 40 simulated 100 times. Okay. So assume the data is approximately normal and the dealership wants to be 95% confident of its results. So 95% confidence means the mean plus or minus 2 standard deviations. Okay, so that's the idea. The mean plus or minus 2 standard deviations. Okay, and determine an interval containing the plausible sample values for which the dealership will launch the new procedure round to the nearest hundredth. All right, so once again, I think I had mentioned this before, but for the simulation questions, like that's the big idea. All right, you're just looking for, once again, you're doing the mean plus or minus 2 standard deviations. That's what we're going to do. So let's pull up the calculator and let's see, we'll go back to the mean here. So 0.506 plus 2 times 0.078, and we press enter. All right, so that's going to be our upper bound of our region, and then we're going minus 2 standard deviations. So then minus, like this, and I'll borrow these values. Okay, so that's like to get the question rolling here, and we have, yeah, so we're doing, the mean is 0.506 plus or minus 2, 0.078, like that. And that'll give us, we'll have an interval here to the nearest hundredth. We're going to have 0.35. Now, I might have chopped this too much, but 0.35, or maybe it goes exact. So 0.35, and then 662 will round to 0.66. All right, so we get this. And now this is where we probably have to read and reread. So after that part, 40 customers are selected randomly to undergo the new check-in procedure, and the proportion of customers who prefer the new procedure is 32.5%. The dealership decides not to implement the new check-in procedure based on the results of the study. Use statistical evidence to explain this decision. All right, so for this one, the reason they're going to decide not to, and we have to use the evidence, is 32.5%. Let's just write this. 32.5% is 32.5 out of 100, which is 0. And we move the decimal twice to the left, or just use the calculator, 325. All right, so 32.5% is equal to this, and this value, so this is not on the interval from before. Okay, so now we just have to think about this. So if this value here, the 0.325, is not in the like confidence interval here, that means like using the statistical evidence, it makes sense for them to not implement this. Okay, so we are just mentioning here that, like, for one, this is our value and it's not on the interval. So then, yeah, using statistical evidence to explain this decision, like, that's the explanation, like that's building our explanation here. Okay, so for these though, before I write my sentence, I do like to reread it. So yeah, once again, the 40 customers that were randomly selected to do the check-in procedure and that prefer it was 32.5%. So they decide not to implement the new check-in procedure based on the results of the study. We're just saying here, so like, since this value here was outside the interval, we could say therefore it makes sense for the dealership not to implement. The new procedure. Okay, and if I wanted to find here is not on the interval here, and I could say like the, you know, the like the confidence interval, like the 95% confidence interval, you know, I could mention that here. So when it falls on the interval, like it's a good idea. If it doesn't fall on the interval, then it's like, oh no, bad idea, and they throw it away. Now let me check the. Okay, so that's that. All right, now for the last one, 6 points. So this one here is some sort of like exponential, probably have to use logs. 6-pointer. And last one, and which is good because we have 20 minutes until 3 hours on this, and that'll just let people then just, you know, that'll be it. This will be it. All right, so a radioactive substance has a mass of 140 grams at 3 p.m. and 100 grams at 8 p.m. Write an equation in the form of A equals A naught times 1/2 to the T over H that models this situation where H is the constant representing the number of hours in the half-life, and A naught is the initial mass, and A is the mass T hours after 3 p.m. All right. So if it's T hours after 3 p.m., this is like the initial time. Okay? Like at time 0, we're at 3 p.m. And it's like T hours after 3 p.m. So like 3 p.m. is time 0. So here, you're like, what we could say, if this were like a function A of t, it'd be nice if they called it A of t, but they didn't. But I could say here, you know, A of 0, I'm just going to work this out, is equal to A naught times 1/2 to the 0 power, which is equal to A naught. And they said at 3 p.m. is equal to 140. Okay, so I could say A naught equals 140. So this is going to be like one supporting piece of information. So now with this, what we could do is next use this piece, 100 grams at 8 p.m. So for this one, I could say, all right, at 8 p.m., that's 5 hours later. Okay, so you see like T equals 5. Okay, because that's 5 hours after 3 p.m. That's what makes this question kind of annoying. So at T equals 5, we have an A value of 100. Okay, so this is like T, and this would be like what A is. So I could say 100 equals A naught is 140 times 1/2 to the 5 over H power. See, H is the constant representing the number of hours in the half-life. Okay? So now we just got to do the algebra here to solve this equation for H. So yeah, we have our equation and now we solve. So 100 equals 140 1/2 5 over H. And now I just divide both sides by 140. And for this one, this reduces to 5/7. You could just do math enter on this, but that one will reduce to 5/7. Okay, I just think of like 10 over 14 divide by 2, top and bottom is 5/7. So this makes 5/7 equals 1/2, and we have to the 5 over H. And then from here, I personally would just natural log both sides. So I could say natural log of 5 over 7 equals natural log of 1/2 to the 5 over H power. And then the 5 over H could just go in front. Okay, so natural log of 5 over 7 equals 5 over H times natural log, make that neater. So 5 over H could pop out in front, and then times natural log of 1/2. And then divide both sides by natural log 1/2. Okay, and I'll move all of this over. So you have space for one more row. All right, so we'll get rid of this. And now what we have next is this stuff canceled. We have over here natural log 5 over 7 over natural log half equals 5 over h. So for this one, I could just flip both sides. That's allowed. This is like kind of annoying algebra, but I guess it is the last question, so they're doing this. So natural log half over natural log 5/7 equals h over 5. And then just multiply both sides by 5. So like times 5 times 5. And that'll give you h equals. All right, I'm going to shrink this stuff down, though, so we have space. So we do this, group. All right, and I'll do the same thing with this. Well, I'll just move this over now. All right, and okay. So we got this, and now h equals that whole mess. So h equals 5 times all this. So now so 5 times alpha y equals enter, and we got natural log of 1/2 over natural log of 5 over 7. And that's going to give us 10.3002. We're rounding to the nearest 10,000th. So that's 4 places out. So 10.32 zeros and a 2. So there's h. That was like really annoying algebra for the start. All right, now final part of this. Determine when the mass of the radioactive substance will be at 40 grams. So now I could write the equation. So the full equation now is A equals A naught is 140. And we have 1/2 to the T over H is this. So now we just plug in 40 for A. Now what I'm going to write here is I'm just going to draw a sketch. So I'm going to use the calculator to do this because they didn't say algebraically. They just said determine. So I'm going to use a graph here. So I'm going to say that this is a graph of A. A is like exponential decay. All right. So, and this one though, like what I could say though, actually let me draw it nicer since it's like decaying like this. So this is A and the initial was at 140. So we want to know like when is this thing going to hit 40? Like down here. So that's 40. And our answer is going to be is going to be at this value here. And to the nearest 10th of an hour. All right. And notice the function is like t hours after 3 p.m. So like this will work. So I don't have to do this algebraically, especially after doing all that algebra. Like I just kind of don't want to. All right. So I just write in our equation was 140. And then parentheses 1/2 to the power x divided by 10.3002. And then we want to know when is this hitting a height of 40. So we press graph and you're like, oh no, I can't see anything. And that's because we have to be able to go up to 140 at least. So how about I go up to like, I don't know, 180. So now I could see more, but then I'm like, oh no, when do they intersect? So window, maybe I go out to like x maximum 30. And I'm like, there it is. Okay, so then I just do second trace number 5. Enter 3 times. And to the nearest 10th, that's going to be 18.6. Okay, so 18.6. So let's just... So T equals 18.6. Okay, so that's T equals 18.6. My A value there would be equal to 40. Right, so, and like determine when, I would just say, yeah, T equals 18.6. And that gets you full credit. Like you could even comment like, oh, this is the intersection. If you want to say like even like second trace 5, like they'll be like, oh, that's what you did. All right, cool. So that is that. Oh, Alisher, nice to see you from AP Calc all those years ago, right? If it's the same, nice to see you. Let me just send that. Yeah, loving a thumbs up. Thank you for stopping by, and I hope you're doing well. For one, I just want to say, go back to the table for like 5 seconds, please. What table? Bless. If you could say like what? Oh, the table like the calculator like this here. What I had, or like second graph. What table are we talking about? I don't know. If you give me a little bit more to go by, I'll go back. But for one, I just want to say, good luck, everybody. Thanks for stopping by. I hope this helped, and it does mean a lot. A lot of you are on here, doing well and working hard. And I saw someone write, why am I here? Everyone's on vacation. I'm proud of you for being here when school is going to end in 2 days. That more than 3,500 of you were like, hey, I'm going to learn a little bit of math, even though it's the end of the school year, where some people may have just checked out, because this is the last Regents. So for you to stick it out to the end like this, I'm proud. Okay, so good luck to everybody. I'm rooting for you. I hope you do well. But no matter how tomorrow goes, I'm proud of you if you're on here watching this, or even like anyone else who's studying from afar. But at Aiden, I'll try to find a way to Aiden, could you write in the chat what time all that yearbook stuff is happening? Because if I have to come by a little bit early, I will. Because they need me in at 11 to start grading, but I'll try to see what time it is. I'll sneak by the barbecue to sign yearbooks. I'm more than happy to. All right, but good luck, everybody. All right, I hope you all do well. So take care. All right, let's see. Signing out. Oh, it's at 12. All right, Aiden, I'll do my best to. I'm pretty sure, unless they need me to do some annoying stuff, for the Regents, but I should be. I'll try to swing by and sign autographs.